Alright, so let's continue on back where we were at previously, which is over here. Alright, so we left off with wrong one. Alright, so we left off over here at text submitted. Okay. And we need to now process this. So we have const CEGUI window event args, which is arguments being passed on for events when it's like clicked or some action that happens here. We're going to store it into args here. We're going to do a static cast here of const CEGUI : window event args here, and then doing a pointer and then close that sorry, is greater than and event here, which is a pointer to event for the memory address. Okay. And that's open and close greater than less than signs around here. So it's not like an expression like greater than. So don't get confused about that. You can get confusing when this is all put together like this, but instead we're accessing it. Think of like, we'll get into this later on, what this means here. Not within right away. When we start doing our own setup like this, we'll get into how this works in depth inside of C++. Just think of it like when we were doing the vectors earlier, how we could access the elements and how we did the, defining the type or whatever. We'd have to sit there and put in the type inside here. This is essentially the same thing. So I'm not going to get into explaining how that stuff actually works underneath the hood yet. We will get into that for the C++. Alright. CEGUI : edit box star here space edit box window equals static underscore cast, and then again CEGUI : edit box star here, and this is inside this greater than less than here, open parentheses chat window arrow get child in quotes chat window / chat client EB close quotes close parentheses semicolon. Alright, so here we're getting our edit box. Okay. Setup that we did, and this is the name of it here. So here we have our message and chat window get child chat window / chat client EB get text. So we're going to get the text that someone types into here. We're grabbing that right now with that line of code. So I'll come back over here, and that's exactly what we're doing. We're doing this get text, and that's how we're getting that, what someone typed in at that edit box line. And don't forget the edit box is this part right here. Okay. Okay. Before we were just getting the name here. Okay, and then we're going to have this parse text message, MSG. And this is calling our parse text function, or shall we say method, inside of our class, down here. And so that's why we have to say this, because it's pointing to ourselves again. We're pointing to this class that we're defining. So because we're pointing to ourselves, that's how we're able to access parse text within inside of this structure here. Where parse text went. There it is, parse text. Yeah, that one. Okay. And that takes care of this. And basically we're just sending the string that we grabbed from, okay, so someone typed a string in here into the edit box, right? We grabbed that and we stored it into MSG, and then we're passing MSG into parse text to be processed for the text. Which we'll worry about here in a bit when I go over parse text here at the end. Chat window here, arrow over to get child, open parentheses, prefix plus chat window here / chat client EB, close quotes, close parentheses, arrow to set text, open close quotes, close parentheses, semicolon. Okay, so what does this do? Well, we're doing a callback to the edit box again, and now that we've processed the text, we're now setting the edit box back to nothing for its text, which is to say whatever someone's typed is going to disappear after that gets submitted. And I can show you this and prove this actually works this way. So let's just go ahead and run this real quick, and let me show you how this works. Okay, so I'm just going in here. I'm going to say I don't know, text for instance, or test. Test works fine. Alright, so you see, as when I submit it, guess what happens? The text disappears from the edit box. So that's exactly what we just did. But the parse text aspect went through it and then eventually ended up into the list box here. So we'll get over how that works here in a bit. But for now, that works out great. Alright, so that's pretty much covers how that text got wiped out there. Here's a return type, true. We always return true. It does nothing. But you do have to have this as a Boolean return type. If you do not, for your events, it will not work. It will not compile. You will get errors. So make sure you have that set to bool and make sure that it returns true always. Just do that. That's what you have to do. Otherwise it won't work. Bool chat window, colon colon, send button pressed, open parentheses, const space, CE GUI, colon colon, event args, and event close parentheses. So again, we're passing in another event. And we're doing this via the send button. It's being pressed. And why is this? Because, well, we're having to do that with this functionality here. So it's sending over the event that occurred, and return type on this is true or false. Remember, that was part of getting those events that are occurring as part of the register handlers. Okay. So inside of the press send button, it gets pretty easy. CE GUI colon colon string MSG equals chat window arrow get child open parentheses prefix plus in quotes chat window slash chat client EB close quotes close parentheses arrow get text open close parentheses semicolon. Okay. So what does that do? Well, we're saying if someone clicks the send button as opposed to clicking on the edit box, we're going to grab the text from this edit box here. And that's exactly what's happening. We're going to then parse that text that we grabbed. So we're going to then process the text that's within inside this edit box when someone clicks on this button. Okay. And then we're going to say chat window get child prefix plus chat window slash chat client EB close quotes close parentheses arrow set text open close parentheses and quotes inside of that semicolon. What does that mean? Well, essentially that means that we're going to then, after it gets parsed and processed, we're going to set the text back to nothing again. And this is when someone clicks on the send button. Return true semicolon. Again, it's going to be bool here. That's going to be the same for all the events. Make sure you always do that for all your events. Close curly brace. And then we're going to do the next one. Bool game chat window colon colon output text open parentheses CE GUI colon colon string space message comma CE GUI colon colon color space color close parentheses open curly brace. Alrighty. What's this about here? Well, still pulling it over. Still pulling it over. Good grief, I can't fit it all. Alright, well, it was a valiant effort, I guess. Yeah, it's as far over as I can go. Alright, I'll just scroll it here in just a second. Okay, so bool space game chat window colon colon output text colon open parentheses CE GUI colon colon string space message comma CE GUI colon colon color space color close parentheses. This is the English spelling of color, not the US, like England English spelling. open curly braces. Alright, so CEGUI, list box here, space, star output window equals static underscore cast. And then we'll have our greater than less than signs around our list box here. So we're doing CEGUI list box here, star, and open parentheses here, chat window get, and then here what we're going to get? We're going to get the name of that chat window. And the name of that is going to be, in quotes here, chat window / chat server messages list, close quotes here, close parentheses, semicolon. So for our output window, it's going to end up having the name of chat server message list here. So that's what ends up being the name for it, and it gets assigned that value. CEGUI : list box text item space star new item equals 0 semicolon. Okay, so we created a text list box text item, a new one anyways. New item. And this is a combination where we're showing how you can use the XML to be read in, and then also generating it on the fly at runtime, some of these extra controls or capabilities without using the XML. And we can do both, and for doing like spontaneously generated controls or whatever, like for instance these extra lines, it's really useful to just run it directly inside C++ and not do it at all in XML for that part. So when we're going to be adding new items to the list, we need to do that in runtime in C++ and not in XML. So new item here equals new CEGUI : list box text item here message comma CEGUI. Now remember, message is what was passed in, so it's that string that got passed in. And where did that string come? It came from either the send button or text submitted. So either one. And in this way, because we are doing it through the output text here, going to the window and just handling it one set of methods here, and we're going to do parse text, we don't have to have multiple submission methods done. We can use just one function to handle it for both. And so that's what we've done here, and it makes life a lot easier and a lot cleaner. So message here, and then CEGUI : HTF underscore word wrap underscore left underscore aligned close parentheses semicolon. Alright, so this lets you have word wrap, so it wraps around to the next part if it runs off, and it's aligned to the left, which is great. And then we have our new item here, set text color. So here we're setting the color of our new text item inside of our list box. Yes, it can even be colorized as it gets listed, which is really sweet. And then output, like Crazy Eddie's awesome. Output window, arrow here, add item, open parentheses, new item, close parentheses, semicolon. So this basically adds that new line of text that was just inputted into the edit box to the actual list box here, which is to say that the text is going to appear here. So essentially someone typed it in here, they've hit one of these buttons, they either clicked on this or they clicked on the send button, right? And it submitted it through parsing text, and after the parsing text it gets to the output one, which is going to make it display in the list box here, and it's going to get colorized and all this fun stuff. So great, that's exactly what we were looking for. It gets submitted as a color, and the color is passed in, so the color can be whatever you want it to be actually, which is really nice too. Okay, so let's look at parse text, because we've been talking about parse text quite a bit here for the function, and let's talk about what it does before it actually gets put onto the window. And so basically it processes the text. I've been saying it's processing the text, but how does it process the text? Let's look at that now. Okay, so bool here, chat window, : parse text here, CEGUI : string space in MSG close parentheses, so incoming message. Basically it's going to be a string, and this is our parse text. And of course it's Boolean just like all the others, because again it is an event. So if it's an event, it has to have a return type of bool. Alright, so std here, I just need to pull that up. And I agree with him, I love using std string also, that's my favorite. So std : string here, space in string, space equals in msg dot c underscore str, and the C here converts it to a C string. So that makes life easy when you're trying to make it correspond back to C style strings. And C++ basically created a mechanism for doing that, and it makes life so much easier. So very important, and it makes life a lot better, needless to say, yeah. And certainly it's going to make it easier for us. So CGUI string comes in one way, and it gets turned over into a C++ string. And I definitely have a preference towards C++ strings too. So if in string.length here, so if the .length operator, you can find out how long the string is. Bada bing, there you are. Is it greater than or equal to 1? It show what that does is to say that our string is not empty. So someone didn't submit a string that had nothing in it. For instance, say we run this. We are not going to process a string that has nothing in it. We only process a string that has at least one character in it. So very cool, because of that one setup right there, it basically prevents nothing being sent to the server, and keeps things from being processed in a, well, in a not so great method or manner. Okay, so there we are with that. So it determines the length of it. So if in string at 0 equals slash here, check the first letter is a command. So is it a command? Yes, and we're doing the slash setup for our server too. If you remember right, slash exit, for instance, was a command for exiting the server for a connection for the client. And we'll be passing that over. And this is quite common in a lot of chat programs, especially if you see like IRC or whatever. Yeah, they use a slash a lot here, so that works out pretty good. And it's great. Open curly brace here, std : string : size underscore type here, space command end equals in string dot find, and then here open close parentheses with quotes around it, comma 1 close close parentheses semicolon. So we're finding the spaces here, and string command in string dot substring here, 1 command -1 command end. So, and of course our command end got assigned when we found the space. So that's the end of the command. So for instance, you'd say like slash, exit or slash quit right here. The moment you hit the space, that was the end of that command. Hopefully that makes sense. So we now know where the end of the command is. Now we can do a subtraction from the end of the command, starting with 1, going to the end of the command -1 for our substring. And this way we can extract out just that partial part of that string there, to where we only end up with the command. For instance, like slash exit, this would give us, just exit. Because we know the first one here is the slash, we don't get the slash in there, we're leaving that out. And this leaves us with just the actual exit text altogether, and with the slash cut out. This also leaves us with out the space. And the reason why we do -1 here from the end of the string is that subtracts the space for the last part here. So we end up with just exit, for instance. So just as a real quick way, let me actually run the application, help hit this home a little better. Okay, I'm going to do a slash exit here. So click that. Bam. Well, it doesn't know slash exit, but anyways, there you are. That's a good example of it, though. So as you can see here, the slash would be ignored, and then whatever space thereafter would be the end of it. So I don't know, quit for instance. So you see here that we have our slash here would be 0. So if we leave that out and we go to 1 and we go all the way to that last part, there's a space. So that's the end of that command, right? So if we cut it back, our range here is only this part right here for the quit. So you can see where the quit is and where it begins and where it ends and all that. And that's exactly what we're doing for extracting it. So we can extract /say, /quit, /exit, blah blah blah, which is nice. Well, in this case /quit, which does a /exit. Alright, so there. So now we have our actual command. And now we can get the command arguments. Was there arguments passed in with the command? If so, what would they be? So in string sub str here, command +1 comma command end, right? So we're going past the space, so it'd be the very next thing after the space, right? In string dot length here, so finding the length here, minus command end +1. So we're finding it, we're doing the length of the string subtracted from all the letters that make up our command earlier, which in our case was like /quit earlier or something like that. So you have one like /say, and then this one's going to say something thereafter as a special command. That next part that they type would be the arguments to that list, to that command. So that's essentially what's being done here. So let me give you a better demonstration of that. Let me run this real quick again. So in the case of like /say, alright, so what are you doing, etc. like this. The /say here is going to be the command with the space here is being subtracted out from the rest of it. And when you subtract out the rest of it, you get just what are you doing with nothing else. And so this lets us separate out and cut out that string separated from the actual command /say. So very cool and very powerful indeed. So that's what's going on there. For std : string : size _ type I equals 0. Let me space that out because I like it to have spaced. So we're doing a size type here, and then we're saying I is less than command dot length I ++. Command I equals to lower command I, close parentheses here. So we're converting the command to lowercase. So if someone were to type it in uppercase, it will get made lowercase. Let's see if I can't show that. Hopefully it works. I haven't played with that yet. No, it didn't. Oh well. Well, that's what's going on here anyways. It's converting it to lowercase. That's happening with inside the structure. It's not getting displayed back. Okay, it's not getting displayed back to the list box, but that's what's happening inside of this functionality. And that makes it easier when you go to do these tests. So if someone did uppercase /say, it still comes out as lowercase /say. So that way you don't have to have lots of different if condition statements that handle different types of processing, because you made all the different characters lower case. So that just makes your if condition statements way simpler. It's the way to go. And it's a standard programming trick and method that's done a lot of times. You'll see that in a lot of different places, a lot of different code. That's quite common. And it does help speed up and simplify your text string comparisons and tests to do your tests. Totally. So if command equals in quotes here say /say here std : string output string equals u : in quotes around both of them plus in string semicolon. Alright, So the out string starts adding U colon to it, and plus whatever the in string is. So the string that came in from the original command, and it says U here. This output text out string here. Okay, so it should be adding U colon to it, to whatever you're saying, and displaying it in our out text box. I don't think it actually does though. That's what it should be doing though. Yeah, it's not recognizing it. Oh well. I guess the thought counts. Alright. I'd have to go back and look at that. Close curly brace here, else if command, open parentheses, command equals in quotes here, slash quit, close quotes, close parentheses here, open curly brace, network.send, slash close parentheses, close open and close quotes and parentheses here, slash exit, semicolon. What this does is basically lets us disconnect from the network for the connection. So you can see when it receives the slash exit command here, it terminates the connection, and we're sending a message to the client that's being terminated. So essentially we disconnected from the server for that client, and the server continues to run regardless, which is cool. Alright, else if command equals quotes here, help slash help, close the quotes here, and you can do a help thing where it lists like all the commands that are possible, blah blah blah, inside your text box, so that someone knows what to do. And that's pretty standard also for a game, well, for a message chat system. So you can basically do your own chat editor like this fairly easily, essentially what we've coded at this point in time. cd : string space out string here equals greater than and less than signs run a string is an invalid command. So for whatever reason, it's not picking this up here and processing it. Instead, it's making it over to this else. So I'd have to see like what's not getting read in properly. The funny thing is when we put in slash quit, it does process the exit command, so, or at least it appears to. Yeah, it looks like it is. Well, I also have it set up to where when the application closes out, it automatically disconnects from the server too by sending an exit command. It could be that it's not processing any of these, in which case there's got to be some kind of read error occurring for reading in the string. I need to see what that is. Oh, I think I know. Dude, totally no slash. I'll explain why. Oh my gosh. Yeah, of course. You still put in a slash. You say. Alright, slash. Simple mistake. Alright, so essentially what's happening is, I don't feel like waiting for this thing. Probably need to edit this part out right here for that command. So that needs to be subtracted from the actual sent message. Could be easily done. Okay, I'll explain what just happened. If you remember right, the command had the slash removed from it because we started at the first character, at the second character, which will put you right beyond this here. So because of that, with the slash put in here for the command, it's not recognizing it because there was never a slash. You'd have to put / say in order to get just, for it to recognize it. So of course that's not going to be kosher and it's not going to work well. And honestly, we only want the part that would be the in-string, the command args here to be passed, and not the actual just in-string to get added to the say. So right here it says in-string. You don't want in-string. You actually want command args. Go in here instead. And I'll show you what I mean. Check this out. Alright, I'm going to do /say. I didn't bother to play with this earlier. Alright. I'm being presumptuous, but wow, it works. There you go, alright? And that works out because, again, I only wanted the arguments which left off the /say part. One other thing I probably want to do with this real quick here would be to put quotes here like this, and this just gives me a nice space. I'll tell you what, I don't need to do that. Easier way, there. That solves it in a simpler method and manner. Alright, so now when I say /say, what are you doing in the game? For instance, I don't know, something stupid. Alright, and now it says it. What are you doing in the game? And that's what you're saying. So that's nice. And it's a simple command. And of course, help, you would just have it display out all the different commands laid out as a submission. So you would submit outstring line for line for what each one did. And you would write up a whole help thing here for this, as far as that goes. So for your outstring, you would say something like, because you would do basically you'd be calling the output right here, output text, for over and over again in here for each one you want to say you want to help on. So you'd say how to quit, you would say how to say a message to other players as yourself, you would say how to disconnect, etc. You'd have your own help command listed in here, and etc., etc. And any other commands you want to say, maybe like team /team for TeamSpeak, or all for everyone. Maybe you want to do something like that, right? Or maybe you don't want to have to say /all for everyone. You would just say, regular command for typing in a message to be sent. Perhaps you have a different one where you could say in the /individual name of that player, and then it would let you talk to that player ID name. So that would be cool, and that'd be fairly easy to do. And you would just pull it up from the list of the players that you got from the server, what's there, and then you would check that list in here from the networking aspect back into this graphical GUI here and see, okay, so here's the names here in the list that's extracted from the server that it sent us, and we're going to get what we're looking for now. And you would probably want to set up to where you will have it, the server just replies strictly to you and not to everyone else as an overall chat system. But that's more complicated than what we're doing right now. But this could be extended into that, and it wouldn't be a whole lot more complicated, just a little bit. And then you would have a fully robust professional chat server essentially for in-game chat. And it wouldn't be like, murder or, brain surgery to pull it off. But essentially that's what it lets you do. So very cool, and really not all that bad, honestly. Here you'll notice that if there is a problem, as you've seen already, you got full demonstration of that. And put the greater than less than signs around the string, and then we're going to colorize it red to let everyone know that, hey, there's a problem. Or angry red color, yes, angry red is really good for that. So this output text here, outstring, CEGUI : color here, and 1.0 F, which is OpenGL F here, 1.0 for red, nothing for green, nothing for blue. Right here, all right, and close semicolon. Close curly brace in this structure for doing a parsing of the strings. Okay, and then we're going to say else. So otherwise, it's all good here. So, and the else had to do with, hey, if we don't have a string that's like has no link to it, if there is something in the string, we're going to output it to the server, to the message box, and we're going to send it to the server, which is what we've been doing. That's why it keeps coming back saying server says, or whatever. That's because I actually have it when it receives. You'll see it from a bit here. Receives from the server, it actually puts in, let us know that that is a server message coming back and not us putting that into the box, which we'll get into in a bit here when we set up the thread for receiving from the server, which is extremely useful. Okay, so this in parentheses around here, arrow over, output text here, in string, open close parentheses, semicolon here. So no commands here, just output what they said. Yeah, so literally it's just going to go straight drop right into the chat window. So here we are, and that's what the output text is going to do. And that's that output text function that we did earlier, or shall we say method, in here where it takes in the message and we're saying, hey, we're going to go to the list box. It was a new item that was created in there for that message, and it puts it into the list box just like we were doing a second ago. So remember how we typed something in here and it displayed it in here. Ta-da, that's it. That's what it does. Alrighty. And then network send. Network.send in string, and this sends it to the server. So, yep. That sends whatever message we're doing to the server. And I probably need to add that to the other aspects too. I just realized I didn't have that for the say. Let's just grab that out string right there, and that whole part right there, and bam, now it's added. Okay, so now it's getting sent to the server, because previously it wasn't getting sent to the server if it got processed with the say command. So there we are. So now the say command, it gets sent over as the out string and not the rest. And of course help's not getting sent over. But anyways, that's all. And then we're going to return true for this function. And then here's the destructor if we need to destroy something that was created in memory with inside this thing at the end. So if we needed to free anything from memory, we could do it there. Which would be great, but we really didn't have to do that. So this is still on the stack, I believe, and not on a heap. So we should be okay on the RAM, so we didn't do a new statement in here. If we'd done a new statement, we would have to delete it in the destructor. Okay, so with that, that covers the whole chat window and what it takes to make it work. Now, we haven't done yet. It's not going to work if you try to compile it for several reasons. And here's two of them right here as to why it won't work. So we're going to go through how we code up the client system and how that's really simple and straightforward on that for the SDL. And then we'll go over how to actually compile the XML parser. So, well, because we need tiny XML, we'll get into that and how to process that for yet another build for CEGUI, which you guys should be getting very familiar with at this point in time. Alright, though, that covers this part of the chat window, and that should get you going as far as that goes. My name is Nate Nestler, and this has been the chat window for CEGUI for the SDL client server type communication programming. This is for Hyperactive Studios. Thank you very much.